Very good morning, children. Are you ready? Let's discuss force and pressure. In this chapter, we cover the following points: definition and unit of force, force are due to interaction, exploring force, effects of force, types of force, definition and unit of pressure, pressure exerted by liquids and gases, atmospheric pressure. At the end of this lesson, you will be able to define force, list the properties of force, understand the effects of force, distinguish contact and non-contact force, list properties of pressure exerted by solids, liquids and gases, list the effect of pressure on human activities, define atmospheric pressure. Dear children, in class 7 already you have learned how objects move, whether an object is moving faster than the other. What does the distance moved by an object in unit time indicate? You also know that a moving object like a ball rolling on the ground, gradually it slows down. Sometimes it may change its direction of motion. Have you ever wondered what makes an object slow down or go faster or change its direction of motion? We often say that a force has been applied on a ball when it is kicked, pushed, thrown or flicked. Then what is this force? What can it do to the bodies on which it is applied? For the opening of a door, we usually have to push the door handle, and for its closing, we have to pull the door handle. So, in order to move an object, it has either to be pushed or pulled. A push or pull acting on a body is called force, and the direction in which a body is pushed or pulled is called direction of force. Push means a force to move an object away from our body. Pull means a force to move an object towards our body. Pushing, pulling, hitting, lifting, flicking, kicking, etc. are kind of actions in our daily life activities where we usually apply the forces. So now let's see some more examples. Here a man pushing the cart. It means for the pushing he applies the force. The boy kicking a ball. It means he applies the force. Here a group of kids playing tug of war. It is also an example of force. Here both the teams pulled each other. A man pressing the switch. It means he pushes, he applies the force. A man pulling the rickshaw. He also uses force. A batsman applies the force to hit the ball and change the direction of the ball. Here the girls, they pulling each other. For the pulling they apply the force, they uses the force. Here the cow and the boy, by using the force, pull each other. In this diagram, a man is standing behind a stationary car. The car is at rest. Will the car move due to his presence? No. Suppose now the man begins to push the car. It means he applies force on it. The car may begin to move in the direction of the applied force. So, from this example, we can infer that at least two objects must interact for force to come into play. Thus, an interaction of one object with another object results in a force between the two objects. So, forces are due to one interaction. Now, we discuss the exploring force. Here, a heavy box is present. If one boy pushes the box, then it becomes very difficult to move. Then two boys, they push the box. Both the boys push the box in the same direction. It becomes much easier to move the heavy box, because when both apply their forces to push together in the same direction, the two forces add up to provide a much bigger force, and this bigger force can move the heavy box very easily. Here the two boys, they give the force F1 and F2, so the net force is sum of these two forces. If two forces act on a body in the same direction, the net force is the sum of two forces. Then here two boys, they apply the force, or they push the box in opposite direction. So the heavy box moves in the direction in which a larger force is applied. If two forces act on a body in opposite direction, the net force is the difference between two forces. Here the two forces are F1, F2, both are acting in the opposite direction, so net F2 is greater than F1. So net force equal to F2 minus F1. The effect of force on the object depends on the net force acting on it. Suppose two boys push with an equal force. It means F1 equal to F2. Then what is the net force? Then here the net force is 0. Force has magnitude as well as direction. The SI unit of force is Newton, whom symbol is capital N, and the CGS unit of force is dyne. You cannot see a force, but you can see what it does. You can also feel the effect of force on your body. So let's discuss what are the effects of force. Here in this diagram, a player stops a moving object. So for stopping the moving object, he applies the force. So a force can make a moving object stop. Here in this diagram, a trolley is there, and trolley is at rest, and the boy pushes the trolley. So pushes means he applies the force to push the trolley. So a force can make an object move. Here the batsman applies the force to hit the ball with the bat, and the ball changes the direction of the motion, and also it changes the speed of the motion. So a force can change the direction of a moving object. A change in either the speed of an object or its direction of motion, or both, is described as a change in its state of motion. State of motion means it is the change in speed as well as the direction. An object may be at rest or in motion, both are its state of motion. Thus, a force may bring a change in the state of motion of an object. Let's discuss another effect of force. When we squeeze the lemon in our fingers apply the force to extract the juice from the lemon, and it causes the change in the shape of the lemon. So a force can change the shape of an object. Let's summarize what are the effects of a force. A force makes a stationary object moves. It stops a moving object. It changes the speed of a moving object. It changes the direction of a moving object. It changes the shape of an object permanently. It also changes the shape temporarily. So these are the effects of a force. Then we discuss what are the different types of force. Force are of two types. One is the contact force. Another is the non-contact force. Contact force includes muscular force and frictional force. The examples of non-contact force are magnetic force, electrostatic force and gravitational force. Here, a book is placed on the table. Can you push or lift the book lying on a table without touching it? No. Generally, to apply a force on an object, our body has to be in contact with the object. So, this force is known as contact force. So, contact force can be defined as a force which can be exerted by an object on another object only through physical touching is called a contact force. When we push an object like a book, we apply the force. Where does the force come from? This force is caused by the action of muscles in our body. The force exerted by the muscles of the body is called muscular force. The force exerted by the muscles of the body is called muscular force. Both human beings and animals exert muscular force to do work. The human beings exert muscular force for performing the various day-to-day activities like cycling, jumping, walking, running, climbing, lifting, pushing, pulling, kicking, stretching, squeezing, twisting and pressing the objects. Animals like bullocks, horses, camels, donkeys, elephants also use muscular force to perform various tasks. Since muscular force can be applied to an object only when our body or body of an animal is in contact with the object. Therefore, muscular force is a contact force. Here in this diagram, a ball moving on the ground slows down gradually and stops after covering some distance. We know that a force is required to stop a moving object. Already we had discussed in the effects of force. This means that a force is exerted by the ground on the moving ball which opposes its motion and brings it to a stop. This force which opposes the motion of ball on the ground is known as frictional force. Some more examples. If we stop pedaling a running bicycle, it slows down gradually and stops after covering some distance due to the frictional force between the tires of the bicycle and the road. This frictional force opposes the motion of bicycle and brings it to a stop. In this case, the two surfaces in contact are the surface of the road and the surface of tires of bicycle. So, the frictional force can be defined as the force which always opposes the motion of one body over another body is called frictional force or simply friction. It arises only when the surfaces of two objects are in contact with each other. Therefore, frictional force is an example of contact force. But there are some forces which act on an object even from a distance. They are non-contact force. So, the non-contact force can be defined as a force which can be exerted by an object on another object even from a distance without touching each other is called non-contact force. Its examples are magnetic force, electrostatic force and gravitational force. So first we discuss magnetic force. The force exerted by a magnet is known as magnetic force. We have already studied in class 6 that the like poles of a magnet repel each other, whereas unlike poles of a magnet attract each other. This means that there is a magnetic force of repulsion between the like poles of two magnets and there is a magnetic force of attraction between the unlike poles of two magnets. See the another example, another diagram. The magnet exert a magnetic force on objects made of iron, steel, nickel and cobalt. Here it attracting the iron pins. A magnet can exert a force on another magnet or on magnetic material even from a distance without touching the other magnet. So it is a non-contact force. Let's discuss another activity to understand it better. For this activity, we take a pair of bar magnet and three pencils, three round pencils which acts as a ruler. So on these pencils, we put one magnet over it and another magnet we held in our hand. When we bring the south pole of magnet to the south pole of the another magnet, then we see the magnet which is on the rollers, it moves away. So this shows the unlike poles of magnet exert a magnetic force it shows the like poles of magnet exert a magnetic force of repulsion. And then we bring the south pole of handheld magnet to the north pole of another magnet, and here we see the magnet which is on the rollers, it moves towards each other, towards the magnet. It shows the unlike poles of magnet exert a magnetic force of attraction. Then we discuss the electrostatic force. Before discussing the electrostatic force, we should know what is the meaning of electrostatic. The fundamental property of matter which take part in electric and magnetic effects is electric charge, as the charges are of two types, that is positive and negative. So the term electrostatic refers to stationary electric charges. An object having stationary electric charge on it is called electrically charged object. Force exerted by an electrically charged object is called electrostatic force, which can be either attractive or repulsive. So let's discuss an example of electrostatic force. A plastic straw charged by rubbing with paper attracts a suspended uncharged plastic straw. A plastic straw charged by rubbing with paper repels a suspended plastic straw charged by rubbing with paper. It means like poles repel each other and unlike charges attract each other. Like charges repel each other, unlike charges attract each other. Now consider another example. When a plastic comb is rubbed in dry hair, gets electric charges and exert an electrostatic force on uncharged tiny pieces of paper and attracts them. The electrostatic force can be exerted by a charged object on another object from a distance. So it is an example of non-contact force. Now we discuss the gravitational force. The force of attraction between any two objects possessing mass is called force of gravitation or gravitational force. The gravitational force between two objects is a force of attraction and it acts even if the two objects are not connected by any means. So it is a non-contact force. Gravitational force exists everywhere in the universe. It is the gravitational force between the sun and the earth which holds the earth in its orbit around the sun, and it is the gravitational force between earth and the moon which holds the moon in its orbit around the earth. The gravitational force between two ordinary objects having small masses like two stones, two books, or between you and your friend, between you and me, is very weak, and cannot be detected easily. The gravitational force becomes strong only if one of the objects has a huge mass like the earth. Earth has a huge mass, so it attracts every object towards it. So in this diagram you see a ripened fruit falling from a tree falls down to the earth. Earth pulls towards itself, and a ball thrown upward, ultimately it comes down. The force with which the earth pulls the object towards it is called the force of gravity or just gravity. See the diagram. If we push hard on a piece of wood with our thumb, the thumb does not go into the wood. But if we push a drawing pin into the wood with the same force on our thumb, the drawing pin goes into the wood. Can you explain why this happens? Although the force applied is almost the same in both the cases, the drawing pin but what is the difference? The drawing pin has a smaller area of contact as compared to our thumb. Our thumb has larger area. This means that in case of the drawing pin, the area over which the force acts is smaller, and therefore its effect on the wood is much greater. This is because of a physical quantity called pressure. Let's discuss about the pressure. Pressure can be defined as the force acting on unit area over a surface is called pressure. It means mathematically pressure equal to force per area. SI unit of pressure is Pascal. Then what are the factors affecting the magnitude of pressure? First is the magnitude of force. It means if the force is more, then it produces higher pressure. It means pressure is more. Another factor is the contact area. The larger the contact area, the lower the pressure. If the contact area is smaller, then the pressure becomes larger. So here in the diagram, one example is there. That is a sharp knife. Here its area is small, so it cuts very easily. So because its pressure is more. But in case of blunt knife, here it has the larger area, so its pressure is less. Here in this example, if we press a pin, the lower the sharp and pointed end of the pin has very less area. So when we apply the force over it, then it pushes into the wooden block very easily. But in case of this cylinder has the larger surface area. So when we give the force, when we apply the force on it, it does not push into the wooden block because its pressure is less. So now we discuss the applications of pressure in our day-to-day life. First application, sharp knife cuts better than a blunt knife. So the force of our hand falls over a very small area of object produces large pressure. Another application, your school bags, it have wide straps. So the weight of bag may fall over a large area of the shoulder of the student, producing less pressure on your shoulder. Another application, here that is a heel shoes. Here it is a heel shoes, and it means its area of contact is very less. And another, in case of these shoes, that is a flat shoes, here its area of contact is larger. The heel shoes sinks deeper into the soft ground than the flat shoes because weight or it is a force is spread over a small area in case of heeled shoes. So its pressure, it exerting a higher pressure which sinks deeper into the soft ground. But in case of flat shoes, here the weight or the force is spread over a large area, exerting a lower pressure. We have learnt about the pressure exerted by solids. Do liquids and gases also exert pressure? Does it also depends on the area on which the force acts? Let us find out. There are some substances like water, oil, milk, petrol, etc. are liquids which exert pressure on the bottom and the wall of the container. Here the force is the weight of the liquids and the area is the base of the container. So let's an example. Here a tube is there, a glass tube is there, and at its one end it is tied with one rubber balloon. So when we put water into it, the weight of water, it exert a force on the base of the or on the bottom of the container. So the balloon, rubber balloon, it increases in size, it inflated. It means on increasing the depth or the height of the liquid, the pressure also increases. Then in another diagram, see the water is filled in a bottle, and the side of the bottle we make one hole, and to this we insert one tube, and the one end of the tube, the outside end, that is it is tied with a balloon. Then we put water into it, and we see that balloon, it increases, its size increases, it becomes inflated. So from this we know that a liquid exerts pressure on the walls of its container or sides of its container. Then here in another diagram, that is, we make 3 equal sized holes at the same depth of the bottle, and we fill the bottle with the water, and we see that is the jets of water coming out from the bottle, and it falls at the same distance from the bottle. It means a liquid exerts equal pressure at the same depth. So the pressure of a liquid increases with depth, and liquid exerts pressure on the bottom of its container. A liquid exerts pressure on the walls of its container or sides of its container, and a liquid also exerts equal pressure at the same depth. So here see another example. Here take one bottle and make 3 holes. One hole near the above of the bottle, it is the uppermost hole. Then another is the middle hole, and another is the lowermost hole, which is near the bottom of the bottle. Then we fill water in the bottle. We see that the water which rushes out from the lowest hole, that falls at a greater distance from the bottle, and the water which coming out of the upper hole, it falls at a very nearest of the, it falls near to the bottle. It means liquid exert pressure on the walls of the container. If the depth increases, then pressure also increases. Now we discuss pressure exerted by gases. All gases such as hydrogen, helium, oxygen, nitrogen and carbon dioxide, etc. exert pressure on the walls of their container. As we know that air is a mixture of gases which are made of tiny particles called molecules. These molecules move randomly in all the direction and collide with one another and with the walls of the container. As the fast moving molecules collide with the walls, so they exert a force on the walls which produces air pressure or gas pressure. Here in a balloon, the large number of air molecules it collide with the walls of the balloon and create a high pressure. So the air exert a pressure in all the direction. When air is pumped into a bicycle tube by using a pump, the bicycle tube gets inflated due to the air pressure exerted by the collision of gas molecules in air with the inner walls of the rubber tube. These are the examples of pressure exerted by the gases. The pressure exerted by the air around us known as atmospheric pressure. Atmospheric pressure is due to the weight of air present in the atmosphere. Here in this example, that is, a glass is filled with the water, then we put one postcard over it. We press the postcard so that no air is present in between it. Then we just invert it, and we see that that cardboard does not fall down, because that is the outward atmospheric pressure which act in the upward direction. Its magnitude is much more than the downward pressure exerted by the water. So the card does not fall down. Another, when we drink the juice through the straw, it also works on the basis of the atmospheric pressure. So there are some questions to think about it. So airplanes have pressurized cabins. Why? How the vacuum cleaner works? Camel can run or walk on sand very easily, but humans not. Why? Have you ever think about atmospheric pressure on other planets? Do other planets have atmospheric pressure? And one fun question. Write 3 non-contact forces that you have studied. Now take the first alphabet from each of the forces and make a word which means something precious. You do it. Some projects are given. You also do these projects. Let us summarize what we have learned. Force is a push or pull resulting in motion of a body. Force can change the shape of an object. There are 2 kinds of force, contact and non-contact force. Force per unit area is known as pressure. Pressure from solid is due to their weight and acts downward, but in case of liquids and gases, pressure exerted by them is downward, sideways and upwards. That means it exerts force in all directions. The envelope of air around the earth is known as atmosphere. The pressure of the air upon the surface of the earth is known as the atmospheric pressure.